All right, guys, on this we're going to be, we're looking at models of different parent functions. So far, the two parent functions we've looked at the closest are the linear and the quadratic. The quadratic we graphed on the last assignment. And these are the two we're the most familiar with from Algebra 1. But there are lots of different parents, and we're going to look at the different ones. But on the linear, just kind of review. If you remember your domain and range. Domain, your side to side, and your range is up and down. So again, for the line, your domain is all reals. Okay? Your range is also all reals because it goes up and down forever. Okay? And that's your linear parent. Your quadratic is y equals x squared. We graphed that on the last assignment. You remember your domain for the parent. This thing does go side to side, even though you can't really hardly see the arrows on the end. There are arrows there. So this thing goes out side to side forever. But up and down, it does have a beginning point where the vertex is, which in this case is 0, and goes up forever. So our domain, side to side forever, is all reals. And our range is going to be an inequality, where it starts at 0 and goes on forever. So our range is greater than or equal to 0. All right. Now, all right, you need to wait a minute. I'm almost done.
I did whole screen.
Okay. Shh. I'm videoing. All right, square root. On the square root function, this one you're not so familiar with, but this is what it looks like. This is the parent, and then if you take this, if you add 2 to it, it would shift it up, or you subtract 2 from it, it would shift it down. But this is what you start with originally, just like this is the original parabola you'd have. So for the domain for the parent function y equals the square root of x, the domain, if we're going left to right, it actually has a starting point, and that point is at 0 and goes on forever. So that domain would be x is greater than or equal to 0. For our range, it has a starting point. It starts here at 0, going up and down also. And this does have an arrow at the end. And so it goes up forever also if you break it into its two different components, the horizontal and the vertical. So actually both of these would be greater than or equal to 0. All right. All right, here on the rational function, this is the parent. What it's always going to look like, as long as it's not shifted at all, vertically or horizontal, it'll start off looking like this. And this is a little bit different than anything you've ever seen. But if we think about the domain first, the domain, if we're looking at it left to right, this does have arrow and this does have arrow. This is a little different than what we're used to. This thing is getting very, very, very close to 0. And right here is getting very, very close to 0. But it's not actually ever crossing across the axis going either direction. This will not come across to the left of the axis. This will not go below the x-axis. And same thing over here. This will not go above the x-axis. This will not go across to the positive on the other side of the y-axis. So if you think about it, this thing goes left and right, or goes right forever this way, and it goes left forever this way. Because remember, there are arrows on the end of this thing, even though you can't see them very well. The only problem is since it doesn't actually cross the axis, there's a hole there, kind of. Well, it's the same thing here on the range. So it goes up forever and it goes down forever over here. But again, right there at that axis, it never crosses it or touches it, so there's a hole there. So the way we're going to show that is we're going to say that the domain, since it does go left to right forever, except with a hole, we're going to say that it's going to be all reals except x does not equal 0. So we're going to put that slash through the equal sign. And then the range, same thing. It goes up and down forever except for that one spot. So all reals except y does not equal 0. Okay. So that's the rational. A little bit crazy looking. All right. Pause. Okay. All right. If you'll turn over to the back, I actually want to look at the bottom of the back. At the absolute value function. I want to go ahead and do it because we are somewhat familiar with it. We've been working on it a little bit. Now, again, this is the parent function. Remember, parent functions always go through the origin. And if you'll notice on every one of these parents, on the previous page, they did go through the origin, those first three. So this one does too. Now, for the absolute value function, remember that it does, these are arrows, it does go left and right forever. So if we're doing the domain there, our domain is all reals. And our range, however, it does have a starting point, a minimum, and goes up. So we're going to have inequality there. So y is greater than or equal to 0, because it starts at that 0 going up and down. All right. Let me move this down here. Whoops. Let me erase. Sorry. Let me try again.
I just keep on one playing.
No, that's not going to work. Hang on. All right, if we go back up here to the exponential, if your base, that's what that B stands for, is greater than 1, then this graph is going to open up, or it's going to go left to right and curve up. If your B is between 0 and 1, in other words, it's going to be a decimal or a fraction between 0 and 1, then this thing is going to drop down from left to right. So, for our domain, So for our domain, Cole needs to be quiet. For our domain, again, this graph has arrows on the end, but it is not going to cross this x-axis here at all. But this one does keep going. It keeps going to the left, but it's not going to drop down below the x-axis. It's kind of this is going to, later on, you're going to know this as an asymptote. But, so for now, our left and right. So this thing does go to left forever, and it does go right forever. So our domain for that would be all reals. For our range, remember I said it's not ever going to drop actually below the x-axis. So the starting point is at 0, but remember that if it doesn't actually cross it, then it's not actually included, so it's kind of like an open point and goes up from there. So the way I'm going to show that is that the range would be y is just greater than 0 instead of greater than or equal to 0, since it doesn't actually cross that axis. And of course, there's nothing down below either. And that domain and range will actually work for this situation also if you look at it. It goes left to right forever, and again, it doesn't drop. It's just that it's on this side. So an example that you might see here is this might be look like y equals 5x, okay? Here, if it's a fraction, then this one will look maybe y equals 1/5 to the x power, okay? It just means you have an exponent that's changing there. It could be 1, 2, 3, 4, 5, and these are how those are going to look. Now, the last one is a logarithmic. You probably don't have much background information on it at all, but just know that we'll see this one in the future. And again, it goes on forever to the right, but this axis acts as kind of a no-go boundary, which is an asymptote. So if we were going to do the domain there, the domain doesn't actually go on this axis, but it does go to the right forever. So the domain would be x is greater than 0. Now the range, however, this thing drops, it keeps dropping, and because this points up, it does keep going up. So the range actually, if you break it down as two components, does look like that. So the range would be all reals. All right, I just need to make sure that you recognize which one is which. Know that this rebound down here at the bottom of the page, let's see if I can pull it back up. This rebound right here, just know that that is the absolute value. Know that the parabola is y equals x squared. Be able to identify the graph that goes with a particular function. All right, we'll see you Tuesday. Have a great weekend.